from boats? Like, is there somebody just sailing around the world mining Bittensor?
I was definitely deving on a boat down. like I was on a boat. I went from Colombia to Peru. Like there's this like cargo boat that takes like 4 days, and it had Starlink on it, and it was like down the Amazon River. And there's me like deving for Bittensor and for grads on this boat when we first started out. So it's definitely possible to.
You went down a cargo boat on the Ucayali?
Yeah, man. I spent it was 40 quid for 4 days in a hammock, like on the, and it was the gnarliest bathroom you've ever seen in your life. But it was fucking awesome.
I know those boats. Those boats are proper ghetto.
Yeah, there's no luxury on that thing, but it was fun. It was fun.
You can go the other way. You can go from Peru to the Atlantic Ocean. I think it's like $100.
No way, like through Brazil on that.
Yeah. And you know, there you are on a boat with your pet monkey and your Starlink and Bittensor and making way too much money for the amount you need.
Exactly.
Cool. It's always an option. Yeah, maybe we'll get some miners in Antarctica sometime. I think that, but why would you go there, right? Maybe Mali would be it.
Yeah. I'm not sure Antarctica's amenable to writing code. Someone will do it eventually, and I think the first should get some sort of. There should be an incentive mechanism for this, like how many different places you can.
Tell your friends. Tell all your friends, even if they have, you know, arts degrees, to learn how to vibe code and start mining gradients from a boat in the Amazon rainforest. Like if they're just some depressed kid living in their basement, it's like, what are you doing? Vibe code, go to the Amazon, bring a Starlink, mine Bittensor, live the ultimate life. Const wants to be you. Okay. All right, guys. Well, without further ado, we have one of my absolute favorite subnets on Bittensor up on stage. I won't do much of an intro. The only thing I'll say is that I literally thought that this problem was impossible to do. I actually kind of chuckled in my head when it was first suggested, and Wandering Weights has absolutely blown it out of the water, and not only proved it's possible, but that you can be incredibly successful doing something so significant on Bittensor that really, like, it's probably the most meta subnet by far, right? It's a mechanism for an incentive, for a market, for training, or getting machine learning engineers to make models that train machine learning models of abstract problems. So I'll try to explain that to my neighbor after the Novelty Search, but hopefully you can do a better job. And yeah, so take it away.
Great, thanks for the introduction. So this is gradients. I guess we're starting with 101, and I'm going to just leave the slide straight away and just jump into what it is. What we're essentially doing is we're like the middle to the end of the stack, which says that we've already got a model that understands language. So it understands the very rudimentary of English language, Chinese, whatever language. It understands that, but it's bloody useless. Can't answer questions very well, doesn't understand, can't follow instructions, doesn't know anything about your product database, doesn't know anything about you as a person, and you want it to know that stuff. That's where gradients comes in, which is like making the intelligence actually intelligent and usable for humans, as opposed to just understanding language. And so, I mean, this is the new and improved gradients platform in terms of the what it looks like. If you want to start a job, it's very simple. I want to create a text job, which is I want an LLM. There's these different options. We're going to just stick with Instruct for now, and I'll come back to that. You can pick any model that exists on Hugging Face, really doesn't matter. Any data set that exists, doesn't matter. Let's teach it some math. And sorry, my internet is beautiful. Let's just do Vietnamese elementary. Why not? You can automatically select your column so you don't have to think about it. Or in my case, I'm just going to go, this is the question, oops. So the question is the instruction, output is my answer, I save, and then I select number of hours, and I press start training, and that will just go straight off to miners. This pricing is wrong, this is on the dev version, which is the nice new buttons, which we want to show. This will be live as soon as we finish Novelty Search. So that's essentially 101 of what gradients was last time that we spoke. We also have diffusion training, which is that you can add a bunch of images. So I've got some const ones. You can just take a bunch of those and drag and drop them in. So if you add one.
Not this again.
Oh, I'm not going to do it this time. The full, oh God, I've lost everything. 1 second, let me just get the link because I don't have it. I'm going to just, 1 second, guys. Let me just get the link. Because I just closed that off. Bonavert, can you just send it to me again? Because I've just.
Yeah, it's actually live on gradients.io already. We've already pushed all the changes, so you can just.
Okay.
Yeah.
Oh, that's beautiful. Okay, let's just do that. Let me just share these. Let me screen these. I'm gonna have to use just a random fingerprint because I can't remember mine. Cool. So yeah, so you just drag and drop a bunch of images. You can pick any model that's Flux, SDXL, this kind of stuff. You drop your images in. We can also do now. Let me just put one in without messing up this time. Yeah, and so we can auto caption those images as well. Before you had to write out your captions, which is kind of annoying. Now we can just, this is a man with a thoughtful expression, with a patterned shawl inside of a cozy room, decorated with plants, blah, 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 blah. And if I would just do const at the front of that, and I added a bunch of those images, I can then train a model on gradients that you can give it a prompt and it will automatically build different types of consts doing different things. So we have like the flamingos, that kind of stuff. You do whatever you want. So that's Gradients 101, what it is, what it did before. Last time we spoke, that's what Gradients was, and it's still that, but now it's a whole bunch more. So let's sort of pivot to, who are these people that are building this stuff? We mostly come from a research background, the team. It's not a huge team. We try to keep it small and driven. We've got all kind of medals of where we've studied, where we've published. Europe's is probably the best conference in the world for AI. We've published a couple of times in that as within the team. And then same with ICML, ECTV, all this stuff. We've done the back work in terms of being researchers. But I think what all these medals and universities and all this stuff points to more than anything is the people that are hungry. And I think that's really what we, as a team, I think we couldn't care less about this stuff anymore. But it does give us some sort of accreditation that says that we are hungry. And that hunger is then translated into what we've been doing over the last 9 months. Is it 9 months or 8 months since Grads was created? And so our release has been, timeline has been pretty rapid. We've had 5 main releases. Where we left off last time in Novelty Search, so we got to diffusion. So we've had Instruct, Diffusion, DPO, GRPO, and open source. We go into the 3, 4, and 5 in a bit. But what that has meant is like almost 500,000 lines of code has been written, like 4K commits, 5 core releases. We've been moving fast. We don't know what a weekend is, and we love it. And so I really want to hammer that the team is fucking awesome. And it's been a lot of fun getting to this point. And I think, obviously we can't take all the credit. Miners deserve more than 50% of the credit. And they're working equally as hard. But I think that this is a testament to the level of freedom that working within this space allows. Going back to what we were talking about only 10 minutes ago, Const. I think that we are building something from scratch that's ambitious, and we have freedom to do so. And I think, with that plus the hunger, is just great, and we are enjoying it and making progress. So let's have a look at what that progress looks like. There are three like core features that we've added in the last 3-4 months. The first two are mostly technical on like how do we push forward the state of the art in model training, because instruct, which is where we had before, or we still have, is mainly our bread and butter, which is that you want to teach an LLM to produce outputs like the data, which is to say question and answer. You give it a question, what's the answer? You know, that's great, but what the research community found and what model training has found, that doesn't quite cut the mustard, because humans prefer certain types of answers. And that's what DPO training essentially teaches an LLM. Hey, listen, there's these two answers that you could give to this question. I want you to prefer this one. That's DPO training. And what that would look like inside of the app would be, oh, this is the old one, would be, so if we go text, we go DPO, I'm going to grab whatever, it doesn't matter, and then we go DPO, and my internet is going to dance for me. Do I need to remove that? There we go. Pardon me. And so we could auto select, but let me just show you what that data would look like. So the data itself, you know, instead of picking input and output, you're going to pick a prompt, and then you're going to pick chosen and rejected. So you can pick whatever ones, hang on, and then chosen and then rejected. Select that column mapping, choose number of hours, plus go if you had the monies, and this model now will be focused to get the chosen over rejected. So you're essentially going to start to coerce your model, not just to give you the right answer, but to give you the answer in the way that you would expect your customers, your model, whatever it is, depending on your use case. Usually this is stuff like, you know, I don't want you to waffle on for too long, LLM, or I want you to respond with courtesy, or I want you to, if you want to censor it, I want you to censor these kinds of answers. All that can be done with DPO, all that can be done with gradients. The results that we're seeing on that are up there with what you would expect in terms of the research, in terms of the loss rates that we're getting from the tests that we come out. And I think we are I think we're the second platform in the world. There's only 2 platforms in the world that offer the DPO. I think Databricks is the other one. I think GCP also had it when we were looking, but it wasn't functional. It wasn't working properly. Maybe they fixed that now. So that's DPO. Relatively simple, adds in, no problems for miners. That is good to go live as we speak. The second part of this is GRPO. So this is much more novel. This is relatively recent. So the DeepSeek guys, when they released, you know, that DeepSeek moment, a large part of that push forward was because of this new optimization method that they have, which is essentially that you have a reward function. I think it's best to show it. So let's do a GRPO job to show what I'm talking about. So we go text, we can go GRPO, we can select any model that we want. Let's do this little Quenny boy, and let's just, maybe there's some on Hugging Face that make this easier. There is. Okay, so let's do something simple. So you have a standard prompt, so that's going to be my problem in this case. So extra data is something that you can use inside of the function that you define. So we allow user-defined functions, which is pretty cool. So for me, I'm going to go with the solution should be, yeah, sorry, problem. Solution, there we go, these. And so what you have here is that you have a bunch of reward functions that you can pick, or you can create your own. So if we wanted to create our own, we haven't put that onto the main, but luckily I did actually produce this before. So you can say, hey, listen, I want you to reward think answer format. And so the reward function essentially says, hey, listen, LLM, I want you to produce a bunch of answers. And given those bunch of answers that you produce, I'm going to use these reward functions to give you some signal as to which one of those answers that you've given I prefer. And so this is an example where we're saying, I want you to, if you use think and answer brackets, then you're going to get more reward. And as soon as you put this in to your training, then it's going to mean that your answers are going to follow that format because they're going to be rewarded more for doing so. In our particular example that I've just given there, we have the answer is going to be between A and D, right? And so I could come up with this reward function, which I just did before jumping onto this call, which essentially says I want to have my answers such that solution is there. And if you have solution with some letters, then you get some reward. And if you get the correct answer, then you get more reward. And so this is just me messing about for that. And you can select a weight. So, maybe this one is more important than this one. And then you can continue with these two reward functions. You can add more reward functions. And then you set this off and fire away, and away you go. And that's GRPO. And we want to make this is relatively complex. It's relatively state-of-the-art in terms of the research community. And we want to make this as flexible but as user-friendly as possible. And so the reward functions themselves, we've got like 15 or so that we've predefined that are just the basic ones. But we want to open this up to the research community and to companies in general, which allows them to pick any reward function they want. And where we're going with this, and I think when we say where we're going, we're talking a week to 2 weeks. We want to have programming containers within this so that if your reward function is that you want to run some program and then look at the outputs of the program and determine that is determinant of your reward function, that you're going to be able to do that. I think we can get weird and wonderful with this, basically, is the idea, is that we don't want to kind of hammer you in and say, oh, we're going to define what the reward functions are and you can just use them. We want to get to the place where any user, any research group, any company can define any reward function and push forward not just training on gradients, but just the state of the art in general. And so that's where we're going with GRPO, and we're hyped about that. It's really exciting. And miners, again, they've picked up no problems at all. They've ran with it. We're excited to open. This is opened up for the first time today, so that's just opened up to organic traffic. Before this, it was pure synthetic, and it was just using the reward functions that we have. So it's going to be interesting to see how that changes and moves forward in the future as we get customers say, hey, I want this reward function. The only added bit that we have in here is that we do have a human in the loop to add new reward functions in the short term, just for security at first, just to make sure that everything, we're not getting some weird reward functions that would ruin miners or that favor stuff that miners have put up themselves, that kind of stuff. So we need to watch out for that. So there is a human in the loop for that. But essentially it's as you like. You can put whatever reward function you like in there. And then, so that's DPO, GRPO, and then the big one is the open source, and we'll come to that in a hot second. But I want to pivot back just a little bit to what we were doing 2 months ago, along with adding these new features, is that we wanted to prove out this great claim that Gradients is the best performing training platform on the planet. And I want to say that we've probably put together the most extensive experimental work on Bittensor, probably, where we ran 180 plus dataset model time period pairs or sets, and we trained all different types of models and on all different types of data sets across our platform and Databricks, GCP, Hugging Face, Together AI, and I'm probably missing one. And we wanted to see, is Gradients better? And better is essentially that we have some holdout test set that no one sees, and we compare, once you're trained on said data set with said model, who gets the lowest loss on the unseen test set. The answer to that is pretty clear. Like, it's Gradients. There's no real competition here. The only time that we ever didn't win was against Hugging Face on tiny models. And even then, it's within the bounds of noise when we didn't win, and we won 83% of the time. But other than that, it's a clear house. There's no competition. Some of them, it's not their bread and butter. It's not the only thing that they're offering, of course. Whereas Gradients, we're focused on this problem. But it doesn't matter what you chuck at this. Doesn't matter if it's translation, math, code, reasoning, RAG. Like, Gradients is better. And I think we're probably in a position where I would say that if you're a miner on another subnet and you're doing anything that requires training and you're writing your own training loop, stop doing that and come and do it on Gradients. Which is the same thing that we're now saying to customers, which is if you want the very best performance, you need to come and do it on Gradients. Like, there's no reason to not do this anymore. And I think that extends out to, or our whole premise is that if you're going to hire a machine learning engineer, 150 grand a year or 100 grand a year, and you want them just to solve, you've got one data set that you want to train on, instruct, DPO or GRPO, you don't need to employ them anymore. You can just run this on Gradients. And that's the premise of Gradients and where we're moving in terms of our customer offering. But the performance-wise, it's kind of a done deal, I think. I think this was, when we got this piece of work put together, it was a bit of a wow moment for us, where it's like, this is game, set, and match, and it doesn't matter what size model you're chucking at. It's the other thing that we've done since we last spoke, or since we last did Novelty Search, is that sizes up to 70B are now offered. Before, it was only up to, I think, 8. So now we're doing the bigger models. There's no reason why that we can't extend this out to 500 billion, other than it's an open question as to how we navigate putting that work onto miners that is not organic traffic, to train them to get good at that. Because to train a 500B model, you're talking at multiple H200s, and that cost has to be reflected in the organic traffic that we would expect in order to make that worthwhile for us to do. And the other thing is, when you're building, if you're going to build a bespoke model for a company, usually you don't reach for the biggest model. It's unnecessary. Usually an 8B model, if it's trained on your data to understand your product base or something like this, an 8B is going to be able to do that. And so that's where we're kind of really focused on making sure that we are top notch, or the mining pool is top notch. And in that case, sin problema. There's no problems here. So it's not just the text, it also translates into the diffusion model. So Civit AI is the only competition out there, or the only real competition out there. And again, it's game, set, and match. It's a little bit closer than the tech stuff. It wasn't like every single one that we won by a long, long way. What we do see is that in the harder context, which is at higher noise levels, I don't want to go too much into the details of how this experimental setup was put together. Please read. We also released a paper that's being reviewed at the moment for a conference. I urge you to go and have a read of that if you want to know the technical details. But essentially, in the harder context, the harder the problem is, the better Gradients does. If the problem is relatively easy, then it doesn't matter too much whether you use Civit AI or Gradients, or we only just win by 0.6% or something silly. And I think that's just down to noise. It doesn't matter what you chuck at it. The reason that the results are not 100% everything to Gradients in the diffusion space is because you're only training on 10 images. So the amount of data that you're training on is much more reduced, and so the training process is slightly less important, is my kind of intuition on that. But it's still, if you want to train a diffusion model, you should train it on Gradients. You're going to get better performance. And so that was 2 months ago. And we had that moment where we came together as a team and we're like, okay, so this is it, right? We've hit to the point where we didn't expect to get to for a couple of years. What do we do now? Let's go and get this customer base. And so because of the team's background, we already have clients and people that we've worked with or worked for. So we reached out to them. We had meetings with them. They were hyped about the performance stuff, but they really got stuck on the data side of things. which is the conversation usually went, Chris, I would potentially trust with Rayon or gradients, but I can't trust my data being given out to a miner somewhere in the world, and you don't know what they're running. Even if that model does come back and it's really, really good, it's my data that I'm worried about. And so we can make the argument, you can anonymize it. There's no incentive for them to keep your data, but it's not enough. And there's this other sort of niggle that we were thinking as well as a team, which is that the reason that we got into this, and the reason we're kind of hyped about Bittensor and the subnets and our vision as well, is that shouldn't it be open source? Shouldn't it be open? Isn't the idea of Bittensor that it's kind of open intelligence, that it doesn't lie in one place? And what if we have one miner or one mining team that dominates, and their stuff is proprietary? We have no idea what they're running. What's the difference between that and closed AI, really? It's not that different. It is in some ways that the motivation structures for advertisements and all these kinds of things is probably less pronounced, but it's still a thing, right? It still doesn't feel like it's that well in keeping. And so that kind of takes us to Gradients 5.0, which is it's time to come into the light for miners. It's that we want to see what these scripts are now. And the reason we want to do that is that once we have these open source scripts, we can run those on Rayon infrastructure, and we can offer direct to customers, and they can know what we're doing. And also, I just think it's a better thing, and it's really fucking cool to find out what the hell's going on. And so the best way to kind of see what this looks like, what do we mean by open source, is to look at the dashboard that miners have at the moment, which what we have at the moment is there are 2 tournaments that are due to start running, but they run continuously with 24-hour breaks in between, text and image. So text is a little bit harder, which is, if you're a text miner, I no longer want you just to give me your model. What I want is your code. So something like this. This is position 2. I was just checking out. And this is their set of scripts. And what this does is that with this script, I am going to chuck, or the validators are going to chuck, a bunch of tasks at you, and you have to solve those tasks. And those tasks for the text side, if I click on an old text tournament, will be DPO, GRPO, and instruct. So you can see there's a DPO, there's another DPO, there's a GRPO, there's an instruct, and you have to be able to handle all of them. And you have to be able to handle all of them, and you're going to get compared to your peers. You're going to get compared to other miners. And so what will happen is that at the end of the 24 hours, when we're ready to start off on the next tournament, miners will get pinged and they say, hey, what's your repo? What's your hash? And how much stake do you have? The reason we're asking how much stake we have is because we don't want to get to the point where we are supporting 250 miners with tiny, silly tweaks to their repos that makes them unique. And then we're going to have to, pay for all that, or validators have to pay for all that compute to the training. So we want to keep the pool relatively small. So we've kept it to 16. And those 16 miners are then entered into 2 groups. So it's like World Cup style. Inside of a group, you play 3 matches. And as long as you win one of those 3, you're through to the knockout stages. And then that continues as your standard World Cup scenario. And then when you get to the final, you are going to play a boss round, and the boss round is that you're going to play against last tournament's winner, and you have to beat last winner by some alpha in order to be crowned the winner. And if you crown the winner, you get a large amount of emission for as long as your script continues to be the winner. And so the winner of the image comp has been the winner for the last 2 tournaments, which means that they've continually accumulated a decent amount of return. The other sort of nuance to this is that we also want to compare this to the Gradients closed source, or the legacy version. And the reason being is that we need those 2 things to come to be the same as quickly as possible. And until they are, we burn some of the emission, and we give some to legacy. So the better legacy is, the more they get. So they're incentivized to keep going, to keep strong. but we've turned down synthetic on that side, so their costs are greatly reduced. But the whole game here is we want to essentially take the stuff that miners have been doing in the legacy, move it into open source format, and we want to be able to serve that to customers as quickly as possible. That is our reason for existence at the moment, is to do that. That was released 2 weeks ago. I think we've had 4 competitions complete, and things are moving in the right direction. And the expectation is that, the hope is that in about a month to 2 months' time, I'll be able to sit and have the same conversation, but to say, right, we've now got to the point where the open source is on par or close enough on par to the legacy, and we're ready to start serving customers with that, and it's time to turn off or potentially turn off the legacy miners, and then focus on the tournament side of things, which would, we're hyped about. I think it's cool. And the other thing is you get to see some of the stuff that people are doing, like, so what's this text miner has done. They are adding random noise to the input embeddings, and that clearly helps. That's not a super well-known technique. It is a technique, but it's to do that to every single data set. That's interesting. It's that kind of stuff that we're excited. And so the other thing is that if I click here, so this one, you can see the same. Oh, this looks ugly. I mean, the code is never going to be beautiful because we're not rewarding them for beautiful code. But I'm sure this is something to do with the batch size and something, and they've determined, or the model size, and they're determining different learning rates, etc., depending on that. So we're going to see this evolve, and really, really hyped for this one. I think this is, I think it's big. I think it's big, not just for gradients, but for AI in general, is to see what is the configuration for any given model, for any given problem, for any given data set that works best. And we're going to be able to see that, as opposed to just have the best version of that, which is booming cool. So that's 5.0. And so the whole reason for that is that we want to drive revenue. We're in Bittensor for 2 reasons. We want to solve intelligence, at least this part of the stack. We want to solve post-training, and I think that the legacy miners plus the incentive mechanism have shown that that is solved, or very close to solved, or we've got the best in the world at least. And the other side of the coin is that once we have the best in the world, it's like, okay, well, we need to get this out to customers. And so organic traffic has been growing. It's clearly not where we want it to be in 3 more months' time. But as long as that line continues to go, and I think it will, as long as, or it will anyway, even if we don't get the open source on parity. But once we get the open source to be parity, I think that will, I hope that will become exponential, at least from the clients that we'll be speaking to. And that will be repeat business. And the idea here is that we can move to the point where the subnet is not just fully sustainable, but is making, which is profitable aside from the emissions structure stuff, which is, the reason to tear for all subnets, right? But I think with gradients, we're going to hit it. I think we can do it. And the aim is to do that relatively quickly. And if you're interested to know what customers are, like what they're firing at us, it's mostly the 1B models and 8B models, which is around what I would expect from previous life as, serving these customers and being a consultant for these guys. It tends to be the 8 billion model, or it was historically that we would always, that was the thing we would first pick up to train. Because for customers, like I said, they don't need these massive models. They need to have small models that are fast, that do the thing that they care about. The other thing I've just realized I skipped is that you can add custom data sets now. You're not focused just on Hugging Face. There's so many different other things that we've added. Actually, it's been a pretty wild journey. So summary: we have DPO, GRPO. We work hard. We have open source. We have the experimental work, and this is all in the past 3 months or 4 months since we last had a Novelty Search. We have some really exciting news that came through this week. The other thing that we've been doing on the side is we wanted to prove that or show that Meta are no good at doing post-training and gradients is better. And we proved that one, that was fine. That is to say that if you take Llama base and you run gradients with a data set that me and Samaline put together, then you do better than Llama instruct, which is their post-training version. So that's like a general model that can answer any questions, can do chat, all that kind of jazz. But someone rightly pointed out to me on Twitter or X that why are you still messing about or pissing about with Llama 3.2 when, you know, Quenny's here? And which is fair enough. So we decided to repeat the process for Qwen 3, which is to take Qwen 3 base, run Qwen 3 on our data set that we've put together. And the data set we put together, I don't want to pretend that this is my research or mine and Samo's research domain. It's probably not the best. It's pretty good, but there's probably holes in it. But what we have coming out of that is gradients instruct 8b, which is a fine tune of Qwen 3 base. And the aim here is, can we beat Qwen 3 instruct? And the answer is yes. The answer is that we beat it by a decent margin, particularly on stuff like math, instruction following. And so this is your standard LM bench set of benchmarks that you would run. We will release, I mean, the code is just the code. The code is the LM bench. The only slight nuance that we have here is that this is 0 shot. So a lot of the time in papers that you read, it would be like 5 shot, 3 shot. In the data set that we put together, we didn't add shots. Shots are like number of examples that you have to answer your question. So if I say, you know, what's the capital of Germany? Berlin. And then I say, what's the capital of France? Well, the answer is Paris, and I've given you one example already. So that's 1 shot. This is 0 shot, these sets of results. And so there is a little bit more work to be done because I want to add those shots into our data set. And once that's done, we will then trounce the same on the like 5 shot, 3 shot benchmarks, because in those benchmarks it's not as clear cut that we're winning. It's like sometimes we win, sometimes we lose. But on the 0 shot, which is what our data set is, we win. Which is to say that a model that is trained natively on Bittensor is better than Qwen 3 instruct. I think it's reasonable to say that claim. And what we now need to do is to, firstly, we're going to go and find every 8B that's ever been created on Bittensor. We're going to show that this version is better than any of those. Sorry, guys. And then the second part is that we're going to then go find every single 8B model that has ever been fine-tuned from Qwen, and hopefully, touch wood, say that gradients is now the best 8B model on the planet. That's where we want to get to. And there, I don't know, I can't say for definite that I can make that claim right now. In about 2 weeks, we definitely will. And if we're not making that, if we're not able to make that claim because we miss out on something somewhere and there's some other model, some other fine tune, the problem is a data problem. In other words, it's my ability or Samo's ability or both of us, because this has not been our complete focus. This is like a side thing in the sense that we need to build a better data set. But the actual training process, I am so sure that there is no way that you can do better, in the sense of now, don't bother employing a machine learning engineer, just run it on gradients, you'll do better. Which, if you would have told me that we would be able to make that claim in 8 months ago, I would have said you're talking rubbish. We have the hope, of course, and but the expectation is it's going to be like 2 years down the line. But we're now at the point where I'm these results are really cool. There's more details to go into this. Like I said, we got these results not last night, night before. And the other thing is you can try this model, by the way, take a picture. It's on Shoots, jump into it, have fun. It works. There's no, you'll see that it's got good quality. And hopefully you'll be playing with this and saying, okay, well, if I'm going to use an 8B model locally to do math, code, one of the other, some science questions, you're going to use this model because it's the best. So I think at that point, I think let's pause on that and open up for questions and thoughts and the rest of it. Thank you.
How come there's no mention of you guys mining Affine? That's fantastic news too.
Yeah.
I don't care.
Yeah. I mean, I think, like I said, sort of at midpoint, I sort of said that if you're a miner and you are doing any kind of training, or you need to do any part of training to mine another subnet, you should be doing it on gradients. We put together just doing the instruct version. That's sort of simple. The GRPO requires us to have this code container that we're talking about. So the aim is to get that done. We'll start work when we finish this call, and we'll probably get that done by the end of next week. At that point, you'll be good to go. And I think it then becomes about like, how do you design good reward functions, and how do you create good data sets? Not about the training. The training it's gradients. Would be my message.
So I had one question. No, I have many questions. But one of the things I thought about was, will we be able to do video models?
It's something we spoke about. I have no reason why not. Yeah, the structure is such that you can take any task, right? The other thing is not just video models, but also like things like semantic segmentation, object detection, like all this like bread and butter ML that we've kind of like forgotten about in the hype of LLMs and stuff like this. Actually, that stuff is like, people are still doing that. Like most companies are still they're still training those kinds of things. Probably, I don't want to say dominant over LLMs. It's hard to say now. I've been out of the consultancy stuff for a while. But I still have clients reach out that want to do other tasks as well. So there's no reason why not. In fact, you've given me a nice pointer that we will start looking at that. And I think that's probably going to be like 6.0. Why not? I think that there's no reason why not.
Yeah, it's huge. I think it's super exciting to see the speed that you guys have gone at. Like, it's unbelievable. And you've broken through to the other side. Like now you're the best in the world. Okay, so now the question is, okay, how do we do privacy? And it's just kind of like adding these small features around the periphery of the technology. One thing that I always think about when I see this is that you make a good company, that company gets better over time, but companies don't have the innovative speed that a mechanism like something like gradients has. If somebody slows down, if your miners slow down, if they're not, they stop being as good at solving the problem, they just get automatically pulled out and somebody else comes in, right? And that's not how a company runs. It's not as like perfectly competitive. And so what's fascinating is like that we crushed Quen, like one of the most popular, amazing AI companies in the world, at their own 8 billion. But the machine itself isn't stopping. It's not like, oh, okay, we've peaked now, and they can maybe catch up. We're moving a mile a minute, right? It's really exciting. And it's the same thing on ridges, right? It's like, oh, okay, maybe we're at 59%, but we're not at 80% that we need to, or 70% that we need to be. But when we get to 70%, we don't stop at 70%. We just keep going. And so like that's why I think this is super exciting. It's like the flywheel. It's a flywheel that you're creating. The open source aspect I assume that you guys are also hoping that this will speed that up, right? So that somebody can come in to the network, see the open source, best in class open source, learn 90% of what they need to learn to get, up to the, maybe not the best in the world in gradients mining, but close enough that the learning curve is not infinity, right? Which is, I guess, one of the things that might slow down innovation on gradients.
Exactly that. It's also that we start to think that, perhaps there's like two miners. One is using one technique and one is using another, and they don't know about each other in terms of what they're doing. But once it's open source, they're going to know about each other. And then that other technique gets added on, and it's just like this aggregation. So yeah, the limit is going to be the limit in terms of what is actually possible, as opposed to the limit of one miner's mind, which is where the difference is here.
I think maybe 7.0 can be a gradient challenge where you take all of the open source scripts and train a GRPO model or something like this, so that people are auto-MLing the auto-ML.
Meta or meta. Yeah. Anything is possible, I think.
I mean, it sounds crazy right now, but it's actually not. It reasonable, even. We'll probably see it next year. So we're crushing language models. When it comes to image, are we also, one of the best in class in that domain, or like is Midjourney still like way above us, way ahead of us?
Yeah, so these are base models, right? Like we're in the sense of we're already starting from a decent base. These are, for the image side, it's like training a LoRa to be good at producing const images. So it's less clear that there's like a general state of the art, because these are just LoRa's, whereas in the text side, it's like because we built this data set that's kind of like general. The open question is like, it's not something we've even looked at yet, but there's no reason why not to try it, which is, can we build a huge image data set? Very easy to do. And then do the same thing. So we have it. I have no idea. No idea is the answer to that, but let's do it. Diagonal, if you're on the call, take notes. We're going to do that too.
What? So, AutoML is classically used for these somewhat smaller jobs, right? So fine tunes, specific machine learning models. Would you say that as an industry, though, like as pre-training becomes less and less the tip of the spear? When I was at Neural IPS a couple of years ago, this is what Yoshio Bengio said on stage. He said, it wasn't Yoshio Bengio, sorry, it was Ilya. Mm-hmm. He said, the age of pre-training is over, and we're now going to be focusing on effectively, the fine-tuning. And does that paint a picture for gradients that, like, effectively there's no problem that's outside of your guys' domain?
Yeah, I think that's fair. That's a fair characterization, and I think it's true in the sense of, it's like train once for the pre-training bit, like take all of the internet, learn language, and then post that, they're gradients problems. Whether that's like designing reward functions that are going to push forward general AI, or whether that's like specific domains, like learning your product base, that kind of stuff. And I think it's true that that's where the meat is now. That's where all the innovation is coming. Like we already, we can't say for definite there's not going to be any innovation in pre-training, but the innovations are very small. Whereas like there's the big jumps that have happened in the last year. It's all come on the post-training side.
Yeah, exactly. Like GRPO, what you guys now have.
Yeah.
And right now, you guys can't do trillion parameter models like, say, Kimi. Do you think that's a limitation, really, or do you think the field is actually going to go back down to, like what we saw with hierarchical reasoning models, what we've seen with things like JEPA, that the field can go to smaller models and still perform very well? Do you think that is? Do you think that basically brings down the barrier for us to achieve truly state of the art?
Yeah, I think so. There's two ways of looking at it, right? Like the first is that, like I said before, when it comes to customers, things like that, like smaller models are genuinely preferred anyway. But when it comes to like the best AI on the planet, I think it still will probably be a pretty large model. And there is no real limitation in the mechanism and in the setup that gradients can't do that. Is the first part. It's just the motivation to do so, and like how do we make a determination of to like how much we want to put on miners in terms of synth before we have a real drive from organic traffic or from us trying to build that state-of-the-art model or fine-tune that state-of-the-art model. But then the other side of it is like, I'm not sure that you need to train, say you've got a 100-layer beast. Do you need to train all 100 layers to get state-of-the-art even? Because most of those first layers, like they're not changing. They're not changing with post-training. And so the other question is like, do we even need to make miners do the entire thing? And would they even do the entire thing? And at that point, their costs become the inference plus a bit of training, as opposed to training the entire thing. So I think that there's some open questions there. But so I don't see the limit in gradients. Like it doesn't, like trillion parameters, we could do that. It's just, is it cost effective to do that right now for miners? And then the second is that, do we need to do that when at the moment the push is that we need to move to the revenue side of things to make everything self-sustaining? And then it would probably make sense to then say, okay, but then the emission side of stuff, we will then plow that side of things into paying essentially for miners to not waste compute, but to learn how to deal with these really, really big models. So I think the limitation isn't there, is basically what I'm saying. It's just a case of the cost prohibition is there.
Out of technical curiosity, can we actually do a bit of a deep dive into what one of these scripts look like so that people that are listening can understand what an AutoML script is?
Sure. Now you're going to have to pretend that I've actually read this and understood it. Let's see. So let's do his train function struct. What is he doing? So he's got training arguments, packing. So he's making a decision whether to pack the input. So packing essentially means that you, instead of taking one input and feeding that through and adding empty characters at the end to make sure that they're the same size so you can pass in a batch, you essentially pack a bunch of inputs and pack a bunch of outputs, and you get the model to take in a bunch of inputs in a single slice essentially. And so he's making decisions on that. Liga, I think, is a kernel optimization in I think it is Liga optimization. Yeah, it's a Triton kernel, so this is going to be faster training. Whether to use LoRa or not is whether you're going to train all of your parameters or whether you're going to learn a low rank version of those. So in other words, you're going to learn some mapping and then map those parameters onto your originals. I don't know what that is. And then this is making decision as to, I guess he's going to use all of the parameters, find all linear names, so he's going to do something different. So essentially what miners will be doing is that they will be analyzing the problem of the model and making a decision of, given the model, there are these things that I can do. So these things are, am I going to use quantization? Am I going to use LoRa? Am I going to use a Liga kernel? Would flash attention work for this particular model? All these kinds of decision making need to be embedded inside the script, because either you're not going to train a good model, or point blank it will fail if you get it wrong. So if you use flash attention for a model that doesn't support it, it will fail. And then the same when it comes to the data set. What are you going to do here? Decide on the number of steps, max batch size theory, and then I guess they're going to use a some sort of way of dropping back if they get it wrong. So in other words, if you use too much of a batch size, you're going to run out of memory. If you run out of memory, jobs are good and you're out. So you need to make sure they get that right. And if you use too small batch size, you're not going to get through the training quick enough, so you're going to fail. Then so they're blah blah blah, and so that's their main trainer. And then they've got like these other things. So they've got a customized trainer here. So there's some special cases by the looks of it, where error generation config models. So this is, they compute the loss, they make decisions about when to evaluate, because evaluation is costly, but you still need to do it. So evaluation is like, while you're halfway through the training, you need to check, how good is my model right now against some eval set that we haven't seen. Problem is that checking of how good takes time. And if you've only got 3 hours to run a job, when you make the decision to make that evaluation? Like, this is a difficult problem, because you want to do it as often as possible, but it costs time. And so you want to stop at the right point. So different type of saving stuff, then a GPO custom eval save callback. And so I think the thing is, the take home is, it's bloody complicated.
Right.
You know, this isn't like you couldn't put this into one script. I don't know how many lines this stuff is. And then you have these custom stuff, like I said, like this adding noise, which is a research thing. And I don't know if they run this for every model. Maybe there's some models that they add noise, or some data sets that they add noise to stop overfitting, depending on the size of the model, size of the data set model pair. Yeah, it's complicated, right? And then I'm assuming they're going to have some sort of, I mean, we kind of looked at this one here, didn't we? So depending on the model size, and I don't know, I guess this is 15 to 20B, that would make sense, right? So if it's 15 to 20B model, this is the learning rate they start with. This is, they use DDP, number of GPUs they use, et cetera, et cetera. And yeah, so essentially there are so many different knobs and buttons and things that can change. And I don't know how many of that is, but I would go in the region of, there's probably 1,000 different things that you can tweak for any given set of model data sets. 10,000, exactly. Miner's game is like, how do I find which of the parameters to tweak in what ways for each given model data set pair? And it's huge. It's very, very difficult. And you know, gradients is the first place that's even possible, because you're given enough jobs of variation that you're able to even like take on that challenge. And it's pure empirical work, I would say. And yeah, I mean, look, you can see here they've got like specialist stuff. Like if it's this particular model, you want to use a different learning rate. They've discovered that over time, running so many Gemma 2 9B models, that they realize that it needs a special learning rate. So you can imagine the experimental work that's gone in the background for a miner to have come to that decision, and that is now the state of the art. And that this goes across every single aspect of the gradient stack, right? So this isn't just, oh, you know, you do this for instruct and you're done. No, you have to do this for GRPO, you have to do this for DPO. And I think that comes into what you were saying, like the bar is so high to entry for gradients that when we're a black box, basically it becomes very difficult for someone new to come in and stand any kind of chance. Like you're not going to be able to come in and work for a week and be able to compete. So having this as open source means you can come in and you can at least have a starting point to go, okay, right, you know, this is where we start from.
I mean, this is like the symbiosis between open source and closed source, right? When you have fully closed source technology, you limit innovation, you limit growth, because it just takes way too long, and like the learning curve is too steep, the incentive curve is too steep, right? You can't mine gradients anymore, because this guy has done 500,000 tests to find the learning rate that's perfect. So like I think that what will be incredible is you'll see this like back and forth, and what, you know, if you're not going fast enough, you're going to be going even faster when you integrate this open source. And I think it's also like I think it's just better vibes, right? It's more ethical, right? It's really open. You're adding an openness level and a layer that's going to both improve the technology and also be better for the world, right? So people can see what they're running, so your clients and your customers can trust what's being done, but also everybody else in the world can trust. Because I actually had some questions about gradients all this time. I'm like, okay, are the models cheating? Like, how do we really know? When you read that script, you're looking at somebody that is not exploiting, right? You're looking at somebody that is very, very, very carefully choosing hyperparameters in a way to improve the performance of an AutoML script, they're not thinking, okay, I can just cheat wandering weights this way and get around the incentive curve. And so you guys are so far past that. It's incredible. And you're starting to see this like Cambrian explosion of complexity. It's going to get even better with the open source update. And I think also will be a lot of marketing for gradients, like not just revenue, but also just marketing, like showing the world, writing research papers about what you're seeing. You've created a Gödel machine, right? This is a machine that optimizes itself continuously, nonstop flywheel. Wow, how fucking cool.
It's
Amazing.
really
cool. Oh yeah, I actually had a question about, so these scripts, the miner has to run those scripts on their infrastructure. Is that how that works? They gather the infrastructure, and then the infrastructure is organized and allocated by themselves. Is that correct?
No. So the validator themselves runs that infrastructure. So the infrastructure is pretty substantial in terms of the open source side of it. And the reason we wanted to do this is it highlighted a really beautiful problem that exists, and I think it exists in Bittensor in general, in a bunch of subnets, which is that sometimes the incentive is such that it is cost effective to chuck computer problems that we didn't want them to chuck compute at. So one example is that the top closed source miner, who's a really, really good guy, as in, we have backwards and forwards, and he has moved his script into open source, or parts of his script into open source. He's doing it bit by bit. And he said to me, one of the things that we have is that I have this learning rate finder, but the compute that you're offering isn't enough. And I was like, what? Like, we're offering 8 H100s to train a single 70B model, which is plenty. And I said, well, how's that not enough for the learning rate finder? He says, well, what I do is I spin up 32 plus machines. I find the learning rate really, really quickly, and then I drop down to a normal amount of compute for the actual training. And so for us, that isn't really what we want. It's fine, it is a solution, but we'd rather smart rather than compute. And so the idea of the other part of the open source is that you're restricted on your compute. So we know that you're not just spinning up 1,000 GPUs and just solving this problem by training 1,000 different models and then slicing off a tiny bit of money at the top, or because it's cost effective to do so. And so so the infrastructure itself is run within Rayon. The idea will be to move that to Shoots going forward, because it makes sense to use the best subnet, or one of the best subnets. I don't know, it is the best subnet for compute, to do the compute stuff. And then we focus on the part that we're good at, which is the AutoML scripts. And I think, I think within Rayon, and we can kind of really highlight like how we can use different parts of the stack to make the subnet the very best it can be. Because as Rayon, it's better that Shoots has as customer gradients rather than gradients spinning up all these machines and running these things.
That's incredible. Could you, at a certain point, I mean, it's probably more complex, but add features to the scripts where what they first do is build their infrastructure, and you basically give them the credits. They can optimize both the script and the usage. And you could even integrate subnets on Bittensor so that compute is cheaper, like similar to how, say, like Ridges, what they do is that they say, hey, like, you're allowed to use models, but those models are on Shoots, and that's just a cost effective thing, right? And what would be powerful about something like that is when it comes, if you force your miners to integrate with one of the compute subnets on Bittensor, whether it's Shoots, whether it's Basilica, whether it's Liam, if you were able to do that, not only would you be reducing costs for gradients substantially, but also like tying the technology intricately to our world, right? In Bittensor, right? and I think that type of integration is something that we should be pushing for. Maybe not right now. Luckily, you guys have a lot of shit to focus on. You're working your asses off, and there's just no end in sight. Sometimes I think that you guys probably work harder than your miners, which is a good sign. Yeah, that's just a thought.
Yeah, I think it's for sure the trajectory. Like it has to be the trajectory. When that trajectory is realized is an open question, but yeah, it's the way that things have to move.
Because like you give these, like for instance, for a GRPO training, like let's say on a 70 billion per hour model, a really effective GRPO training, wouldn't that require like tens of H100 boxes, like 80 H100s or H200s?
I mean, when we start getting really big models, I guess, but at the 70 beam model, it should be fine, right? Because it's like essentially 3 times inference plus the offset parameters, so it should be fine. For
You mean
8.
7?
Pardon?
Did you say 70 or 7 billion?
70.
Okay.
Yeah, because it's like it takes 2 H100s to run inference on a 70B, right? I guess it's quantized, to be fair. Yeah. There's we haven't had a miner come up to us and say, look, we need more compute for the actual training. But you're right. Once we start moving to even bigger models, which, as I said, like there's no real limitation other than the limitation that we're setting, that infrastructure will start to become even more of a demand, and at that point, it becomes a no-brainer to offset that into the cheapest place, which is going to be on another subnet.
Right. It feels like there's a whole other dimension here that you guys have not explored, which you will explore for sure, which is the cost effectiveness of the models. Like, be the best, but be the best while orchestrating the least amount of compute and taking the least amount of time. Like that dimension is super important. It's sort of like unexplored by a lot of the major AI companies, because everything's just, awash and flush with venture capital money. But Bittensor, because of who we are and the way that we set up the dynamics of dynamic tau, and the token economics of cryptocurrencies, like we don't have that privilege, and because we are forced to get really clear about the economics very early, very quickly, and that's a hard lesson, but it's the right one, and ultimately it makes us very forward thinking. So like the fact that you guys are already thinking this way is maybe something that like the larger AI firms are not thinking, but it will be taking us the extra mile.
For sure. That actually just brings me to the point on this set of experiments I didn't mention, is that the cost effectiveness of some of these, Google particularly, right? When we were training, we wanted to train a bunch of 70B models on Google, and we looked at the price. It was $10,000 to train one, and so that just took apart our idea that we were going to run all 170 models on. That would have bankrupted us. And so they're clearly not thinking about the infrastructure side of it, because then they're not being cost sensitive at the moment, or they're not being price sensitive. So yeah, I think as we, because we want to stay cutting edge and the cheapest, or one of the cheapest, we need to get down the other side of the coin, which is the infrastructure costs. Yeah.
Hell yeah. Can I get a hell yeah?
Yeah.
Well, there's some questions maybe from the crowd here. Is anybody else in the chat would like to come up on stage and ask wandering Waits and Bonneveller questions? Now's the time. Actually, maybe we'll just ask. I'll just read the questions actually. So Easy Trades, can you just type your question out? I think Kakashi is going to be talking about revenue. Do you want to go back to the revenue slide, Wandering Waits, and talk about that?
Let's do it. It's not our proudest slide. It's going in the right direction. And so I think we should probably say that the costs have been updated of late. So let me just, because I can't remember off the top of my head, Let's take, if I was to train GPT OSS with some math, what do they do? This one here, instruction response, save the selection, let's go. Is this not being updated, or am I, I'm on the old one, sorry, that's me. Okay, so yeah, you can see here that this is a small model, right? Yeah, so this is a instruct 3B, and you're looking at 15 an hour. So to train that model would be $100 for a tiny model. But if we go to a big one, so let's do a 70B. Oh no, let's do the OSS, because that's like, people want to train that at the moment. I think the Ridges, not Ridges, the guys on the Fine are interested in this one, right? Let's do some math again. Why does that take so long? Am I doing DPO? Is that what I picked? Okay, it doesn't matter. Do this. Yeah, so the cost of, if you were to do a 20B model, you're looking at $250. And then if you wanted to do the 70B model, I think it would cost $500, to give you an idea of like where the pricing is at.
Right. Which is, you know, just for the crowd here, very possible to mine affine just by figuring out how to get it working on gradients and going to this website and clicking through it. Someone asked, hey, can I do this with Bash? It's like, you don't need to. You could mine affine with Gradient's website. And if you come into our channel, I'm going to be like helping people buy credits on Gradients so they can use this technology and make this connect. I think it's just good for the industry, good for the ecosystem. You can also do it. You can do everything with the API, right?
Yeah, exactly. So that's what I'm showing here. Like you can batch jobs with an API that's like text, DPO, GRPO, the whole thing. Should be super simple. Like you can do custom. Here we go. Custom data sets here. Yeah, that my aim next week is to get some better documentation, not just this, of like how to use the full process, particularly with GRPO, because there's a slight nuance of complication there in understanding what the format should be, to make that super simple to use the API side. So if you want to do a bunch really quickly, use the API, but obviously the front end is beautiful, and if you're just doing one or two at a time, best to use that.
Amazing. All right. Well, I'm sure it's late. You guys are in Asia. You're in Europe. Why don't we end there? What a fantastic presentation. Wandering. Bond, you were somewhat quiet the entire time.
Sorry,
moral support. Fantastic. Super exciting. Let's actually, can you put a link in the chat after the call here, so where we can go and see the Quen model that beat Quen 3?
Yeah, 100. Let me just put that there. Take a picture, but we'll get the link as well. Yeah, sweet. Thank you so much, guys.
Thank you.